So in this tutorial, we'll see how to use the i.MX RT1170 EVK with DeepView Creator to validate a project. This will follow more or less the same as we did previously with the i.MX 8M Plus with the MPU, except now we'll be doing it on an MCU. It'll be the same project, so we'll skip some of the project details while doing this. So first you'll need to download the project from the forum post, and then from there in MCU Expresso you can select import project from file system, and then it's a zip archive, so you can do archive, browse. We have it in the downloads folder here, and then there we go, ModelRunner RT1170. So click next or finish. You'll see there's the one project, the DeepView ModelRunner. So the project, it's based on a LWIP project, provide the TCP/IP stack, and then we provide a HTTP server that allows, basically that implements the ModelRunner interface and supports DeepView RT. Details of the project itself are too important in this case, since we're just looking to use the remote validation and profiling. One note though, by default this will create a release build, and we sometimes run into issues with the board in release builds. Not quite sure what the issue is, but with debug builds, at least for me, I haven't run into it. But if you do run into issues, at least there's potential to debug it. It could be some configuration issue with the related to the SD-RAM. So build the project and then flash it onto the EVK. One item I should cover is the board setup. So here's a picture of the board. So you'll need the Ethernet plugged in. There's two ports on the 1170. We're using the gigabit port over here, and then we're using the DAP right now. You can use the JTAG or the trace tool, but you'll still need the USB plugged in over here to access the console. And then the console, the article has some resources linked for how to set that up. So I'm using just the serial program on a Mac. So I'm connected to the DAP link, same as DAP over here. On Windows you can use PuTTY. On Linux you can also use PuTTY, or just use CU directly. I guess MCU Expresso also has a tool for this, but that's it. This setup's pretty basic. And then so back over here we can now click debug. So I'll pick the DAP. And what's it doing? Doesn't seem to be doing anything. Maybe I didn't have the project clicked. All right, let's click debug again. There it goes. User error. Okay, and now we're in main, and again, what it does is not too important, so we can just go ahead and start it, and then when we switch back to our serial program, you'll see the initialization messages here. it'll go get a DHCP address, and then there we go. Once it has an address, so we can see over here the IPv4 address. In my case is 10.02.13. So this will change for all the setups, and then the port number won't change unless you change it. And by default, we use 10.8.18. So we can now switch over to DeepView Creator, and we'll go do remote validation on this target. So we'll open up the same little toy cars demo, and then we'll open up the same model we trained before. So again, we can go load previous model, and then this is the model we had the other day over here. Then we'll pick one epoch back. It had better accuracy, so why not? So to start, or I guess let's go right to validate. To start, we can quickly click, validate. So we can see what our local score is on the on our PC. Don't read too much into this. There's only 35 cars in there, fairly basic. But with a bigger data set, something like VOC, which we'll cover in other training videos, you start getting more realistic, more significant results. So now for our target, we'll go set validation target. I've already set mine up over here. It's the EVK, and you can see the 10.10.2.13. Click OK, and then we'll ask for a quantized model. So we'll show the per tensor and per channel quantized again over here. And again, the accuracy is a bit funny. We'll see with this particular model, the per channel actually ends up being lower accuracy, which is kind of the opposite of what you would expect. But 35 samples. So if we pick per channel, input, output data type, there is an issue with with signed integer output. So if you try this out, actually we can go see the issue on the local host quickly. So like this, validate. I guess I haven't tried it with this model yet. But typically for output, you're going to want unsigned int or float. You can technically request signed integers, and in some cases there's a bug where you'll see we get the results are all corrupted. So if you see that, it's a known issue, should be fixed. Actually, I believe it's already fixed. It's just not in this particular release. But again, it's not. You wouldn't typically use that. The output is your softmax output, and it makes the most sense as a float number. It gives you a sort of percentage of it's not quite confidence, but how good the inference of that item was. And then I guess it does work fine, but in some cases int8 output is doesn't work well. So uint8 or float32 are kind of what make the most sense. On the input, I guess this is where it's a bit more interesting. So for certainly for DeepView RT, TensorFlow Lite is always also like this. It prefers to work with int8. So internally the model uses signed integer 8 activations. So if you choose uint8, which will match closer sort of by default to your pixels, right? You can give image pixels data directly. It does. You'll see there's a quantization layer at the beginning of the model, and it's not so much quantization as much as requantizing from uint to end, basically just shifting everything over and accounting for the 0 point. Or you can choose float input, and then it'll truly do a quantization as the first step. But again, typically, certainly for any imaging application, we'll want UN date. And again, on the output, UN date is your softmax is going to be some number 0 to 1, and with UN date, it'll just be scaled 0 to 255. If you make it float, it'll use a lookup table to do the matching. So we'll leave them both as UN date for now. And then let's go switch our target back to the 1170. Go ahead and run validation. So it was roughly 76% on our float model. I think 76.68. And there we go. So again, the per tensor uint 70. So it lost about half a percentage. And again, as I keep saying, it's not super meaningful with only 35 samples. And then we have our model evaluation. So we see it's 722 milliseconds over here. And then we'll go switch it to per channel. We saw in the NPU there was a bit of a slowdown when we switched between per tensor and per channel. But the way the implementation works on the MCU, they're effectively the same. There's differences, but they're not very meaningful when it comes to processing time. Go there and select per channel and then run validation again. Now, we would also expect better accuracy typically with per channel. It's already pretty close. It's a very small data set. But we'll see in this case, our accuracy actually goes down. I believe it'll be about 73%. So again, normally you would expect better accuracy from per channel, so you do favor per channel when you can. And then here we go. Yeah, so there's the 73%, and we see model evaluation still took 722, and then I kind of skipped this before. The model input is just preparing the image for the model. So handling the scaling, so the decode. So this image decode will do the JPEG decoding, and then model input will do the scaling to the right resolution for the model. So this model was trained at for 320 by 320 input, and then depending on the image, some are bigger, some are smaller. This number is a bit funny because it'll average over the whole data set. Now, again, it's not a huge data set, but there are some images that are basically some were captured on an iPhone, so they're fairly high resolution. So you can imagine, the time it takes to decode those can be a little bit. And, so we see 915 milliseconds. And anyway, so that's the validation on the RT1170. And then again, we can go look at model tool. So if we were to export this model, so per channel, per tensor, well, I already exported the per channel before, so I'll do the per tensor. And then we can open this model. So again, you go the manage targets, and then we've already configured our RT1170 over here and turned on profile. The other ones are off. Close this and do the profile model. And there we go. And again, the profile, it uploads the model and then it runs 10 inferences. We had it set up for just 10 inferences, so it happens pretty quickly, but that gives you the timing information. So now we can flip that on, and if we look at the timing, we can see, so here's that quant layer. That's really just re-quantizing the input. So from uint, which is what we requested, so this would be an unsigned integer input, and then it re-quantizes it to signed integer. So if we look at conv2d over here, we can see the input is int8. It'll be a bit awkward here if we look at input 1 because it reports as float. This is incorrect. It reports that because that's what the trained model is actually a float, and it's not reporting that this exported model has different input type. But that's really just a bug in model tool that should be fixed. But unfortunately, you can't trust this part. But we can see here, if we look at this quant layer, we see that name input 1 int8. That's the output, is the signed integer, and that's what feeds into this convolution layer. And again, we can see this first convolution layer, 10% of the model time, and if we go down, we see the other times. You'll notice a lot of these are kind of like zeros. The 1170 firmware is currently set up with the clock's just got 1 millisecond of accuracy. On the RT1170 1064, we're using a high resolution clock, so we actually get down into the microseconds for the profiling timing. But I guess it's just not quite working on the 1170 yet, so millisecond accuracy. But it still, gives you, many of these layers are taking more than 1 millisecond, so we still get the pretty meaningful numbers out of this. But for some of these, if you see like a conv that took 0 milliseconds, just means it was just under a millisecond. Anyways, that covers everything for the 1170 for now. Later we'll look at we'll probably look at this more on the NPU, but I guess it's also valid on the MCU. But when we take a bigger data set, so say VOC, and do quantization validation there, then we start to now we start to expect per channel is going to give us better accuracy, and the accuracy report is also going to be more meaningful when we're validating against a few thousand images. But anyways, that's it for now. Thank you.